Hey guys, welcome to the video on linked lists. In this video, we'll see what linked lists are, the types of linked lists, and also what are the pros and cons of using linked lists, and also code for implementing linked lists. Let's of course begin with the definition of linked lists. So, a linked list can be defined as a collection of nodes wherein the node in its most basic form consists of a data field and a field which consists of the address of the node containing the next element, that is the consecutive element. So basically, it's like a train with many compartments, and each compartment can be considered as an individual element, and the linkers of the compartment can be considered as the field which points to the address of the next node. This is a very naive representation of linked lists. Here, every rectangle is a node, and the red arrow is a pointer that leads to the address of the next node. If you've ever played treasure hunt, linked lists are quite comparable. You're given a clue that leads to a location of the second clue, which leads to the location of the third clue, so on and so forth, until you reach the last clue. Now let's take a look at how the structure of a node is. This is how a typical basic node will look like. It will have two fields. First, a data field, which will store the data or information that we want to store. For example, maybe you want to store a list of prime numbers, so the data field will contain one prime number. Or maybe employee IDs or something like that. Whatever we want to store in a list, one element will be stored in the data field. And second, address to the next node or pointer to the next node, which will basically store the memory address of the node which comes after it. So basically, the address of the consecutive node will be stored in the second field of the node. Until now, we were talking about what are called as singly linked lists. So you might be able to guess what doubly linked lists are. This is how a doubly linked list is. It has an additional field, a field that points to the previous node. So there's not much difference between a singly and a doubly linked list, except that doubly linked list has three fields, one for storing the data, obviously, one field for storing the memory address of the consecutive node, and one address or one field for storing the address of the previous node. And this is how a circular linked list looks. As you might have guessed, it's a circular linked list, meaning the last node points again to the first node. Let's look at the pros and cons of using linked lists. First of all, linked lists are dynamic in nature, which means you do not need to give the initial size of the list. Consequently, memory is not wasted. And also, easier insertion and deletion of elements is possible in linked lists. The flip side of the coin, which is the cons, they include more memory is wasted as compared to arrays, as you need two fields, one to store the memory address and one to store the actual information or data. Also, traversing elements is complicated, and so elements cannot be accessed randomly, hence increasing the time of operation. Okay, so we saw the theory of linked lists. Now let's get on to some actual code. Okay, so this is some code for linked lists, and we've created a class node first, which will contain two fields as we discussed in the theory part. First one is obviously the data field, which will store the information or the data or the element or whatever. And this is node star next, or node asterisk next, which will be a pointer to the next element. So that's our class. Next, we're going to create another class called as a linked list. And I'm going to have node asterisk head comma tail. So these two nodes this will be our head node and this will be our tail node respectively. And then we have a constructor here which initializes head and tail to null pointers because we want the list to be empty currently. Also, we're going to have three functions: add node to add a node to the list, Then we have a display function, which will display the nodes or the elements of the linked list, and also a delete node to delete the elements of a node, delete elements of a linked list. So let's look at our first function, which is add node, and we've passed int key as our parameter, which will add that element to our linked list. So first, we're going to create a temporary node here. So I hope you know the syntax of creating stuff here, or you must know basic C++. So first, we're going to create a temporary node, and then we're going to assign the value that we passed as a parameter to the data field of the temporary node. Also, we're going to initialize temp next to null pointer because that's our first element, and we don't have any following or consecutive element after this current element. Now, we're going to check if head is null pointer. Remember, in this class, we initialized head to null pointer because we wanted the linked list to be empty. So this is going to check if it's empty. And if it's empty, obviously the head is going to be assigned the temporary node, and so is the tail, because that's the first and the last node of our linked list currently. Otherwise, that means if the head is not equal to null pointer, that is, if head has some element assigned to it, then we're going to assign our temp node to our tail next. And our tail is going to be equal to tail next. So basically, we're pushing this temp node as the last element of the linked list, and we're assigning tail, so we're naming that temporary node that we just pushed into the linked list as tail. And obviously, we're going to see out a statement saying that this element has been added as a key. This element has been added to the linked list, just so we know that it's been added. So that was our add function. Next, we have a display function. We're going to create a struct node, asterisk n, so that's just going to be a temporary node. Again, we're going to check if head is null pointer, that means the linked list is empty. And accordingly, we're going to display this message that the linked list is empty. Otherwise, if head is not null pointer, so if the linked list has some elements inside it, we're going to assign head to n, which is our newly created node. And while n doesn't equal to a null pointer, so basically, if you can see this, if you can visualize this, the last element of the linked list will be a null pointer, and it'll point to nowhere. So until we encounter that condition, we're going to see out the data field of our node. And obviously, we're going to have to increment, or we're going to have to go to the consecutive node using this statement, which is n is equal to n next. So that was our display function. Now let's take a look at our delete node function. Here, we're going to pass a parameter again, which will be the element that we want to delete. Again, we're going to check if head is null pointer, and then if it's true, we're going to see out that the linked list is empty. Otherwise, we're going to create a temporary node, and we're going to assign head to our temporary node. Again, in the if statement, we're going to check if the data of the temporary node, or the data field of the temporary node, is equal to what we passed as the parameter. That is what we want to delete. And if that's true, temp is going to be equal to temp next. So we're going to break the link between the previous node and the temp node here using this statement. And also, we're going to assign temp to head. So basically, we deleted our first element in the list. Or we deleted the element in the list. And then while temp. So while temp is true and temp does not equal to a null pointer, we're going to use an if statement and compare values again. this statement here is going to assign the data field of the next node of the temporary node as our temporary data field. And same thing here. Next field of the next node of the temp node is going to be assigned to the temp's next node. And then it's going to break, obviously. And obviously, we're going to use temp is equal to temp next to continue the while loop and to stop the while loop from going infinity times, from running infinity times. And at the end, we're going to see out a statement that this element has been deleted from the linked list. Now, this is our main. This is our main, where I created an object of the linked list class. And using that object, I tried to add these elements to our linked list. Then I displayed the element using display. I deleted a node, and then I displayed the list again. Let's see how the output looks. So as you can see, this is how our output looks. Firstly, we added 3 to the linked list. Then we added 10, 20, and 30 to the linked list. So this is our linked list, which has been formed correctly. And then I tried to delete 20 from the list, which is successfully deleted because we can only see 3, 10, and 30. And our program is over. So basically, that was the basics of linked lists. Thanks for watching, and let me know how the video was.